So here we go. Chapter 6 is now done. I know up at the top of this it says 6.1, Properties of Exponents. But the idea is that we're going to look at Chapter 7. Chapter 7 is going to talk about rational functions. And to work with rational functions, you first have to deal with exponents. So let's talk about Properties of Exponents from the first section of Chapter 6, and then we'll go on to Chapter 7. So let's look at this. Let A and B be real numbers, and let M and N be integers, so positive and negative whole numbers. Properties, product of powers property. When I multiply two numbers and my base is the same. Let's talk about powers real quick. Remember, A is the base, M is the, let's get this straight. A is my base, M is my exponent. So when I talk about my base, I'm talking about the number. And when I talk about the exponent, I'm talking about the power. So when I look at this and my bases are the same, I both have A and A, what I do is I add my exponent. So this becomes A to the M plus N. So the example is 3 to the 4th times 3 to the 7th is equal to, well, that's 3 to the 4 plus 7, and that's equal to, that's not a 7, 3 to the 11th. Why does this work? Well, basically what I'm doing when I say 3 to the 4th is that's 3 times 3 times 3 times 3. 3 to the 7th is 3 times 3 times 3 times 3 times 3 times 3. And I think I need one more times 3. If I count those up, that's 3 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, because it's 3 times itself 11 times. So instead of multiplying it out and listing all those numbers like I did in green, all I need to do is add my exponent. So 3 to the 4th times 3 to the 7th is 3 to the 11th. That's the product of powers. When I'm multiplying, the bases are the same. I add the exponents. My next rule is a power of a power property. So my base is A, I have an exponent M, and the entire thing is being taken to the n power. Power raised to a power, I multiply my two powers. So what does this mean? Well, again, if I take 3 to the 4th and I raise that to the 7th power, I'm going to say that's 3 to the 4 times 8, which is 3, not 8. How about 4 times 7, which is 3 to the 28th. Again, how is this working? Why does this work? Well, what I'm doing is I'm taking 3 to the 4th and multiplying it times itself 7 times. Well, how many 3's are there altogether? Well, this is a group of 4, this is a group of 4, this is a group of 4. Up till that's a group of 4, there's 7 of those groups of 4. 4 times 7 is 28. So this is 3 to the 28th. That's the reason why this works. But what I do is I take power to a power. I want to multiply 3 to the 28th. Okay? Well, what happens if I'm taking the power of a product? I'm multiplying two things together. I have two different bases, A and B, and they're both being raised to the same power, M. Well, so that's A to the M, B to the M. So how does this work? Well, again, if I have something like 3 times 2 to the 5th, that's 3 to the 5th times 2 to the 5th. And if I actually multiplied that out, I would actually get a number. What's another example of this? Well, if I have 3x to the 3rd, this would be 3 to the 3rd, x to the 3rd. It's kind of like the distributive property. If I'm taking two bases to a power, I want to distribute that power into both of those things that I'm being multiplied by. Now, in red, I need to make a very good point. There's a difference between 3 times x to the m and 3 plus x to the m. 3 times x, this is 3m times x to the m, through the m times x to the m. 3 plus x to the m is not equal to 3 to the m plus x to the m. This doesn't work. Why? Because I have all the middle terms. When I do 3 plus x times 3 plus x m times, keep putting an x instead of a plus. What's happening? Not only am I going to have 3 to the m, but I'm going to have 3 to the m minus 1 times x. And there's a lot of middle terms between the 3 to the m and the x to the m. There's a lot of other terms here in the middle. So I need to remember that 3 plus x to the m, I just don't distribute in. I can't do that. I have to FOIL it all out and then multiply everything together. So make sure that you do remember that you cannot distribute the power if you have addition or subtraction. It doesn't work. It doesn't work the same. I can only do it as if I'm multiplying. Okay? Let's look at my next slide. The zero product property. The zero, not zero product, zero exponent property. When I have an exponent, a to any base, keep doing that, any base to the 0 power is always going to be 1. So if I have 1,536,287 to the 1 power, it's going to be, to the 0 power, it's going to be 1. Any number, anything to the 0 power is 1. If I come up here and I write this god-awful problem, I write x squared times z to the 25th over 2 to the 7th over y to the 3rd, and I put it all to the 0 power, I can ignore everything because the 0 power tells me that the answer has to be 1. The answer has to be 1. And that's the zero exponent property. Be careful, make sure you understand that. So we were talking about powers, multiplying things out with exponents, with powers. What about division? Let's look at quotient of powers. Remember, quotient is to divide. When my bases are the same, a, and I have two exponents, I subtract those exponents to get my answer. So 7 to the 5th over 7 to the 2nd is equal to the 7 to the 5 minus 2, which is 7 to the 3rd. This works the same way even if I have, let's say, let's not do 3, let's do 9. 9 to the 3rd over 9 to the 5th. It would be 9 to the 3 minus 5, which is 9 to the negative 2nd. Negative exponent tells me to put it in the denominator, and that's 1 over 9 squared, which is 1 over 81. Anything that I know the power of, that I've memorized, I want to go ahead and work out that power. I can leave things like 7 to the 3rd. I mean, if you really wanted to work it out, 7 times 7 is 49. 49 times 7, I think it's 200. Yeah, I'm going to get it wrong. 289, but it's probably wrong. Anyways, 7 to the 3rd, I can write that as 7 to the 3rd. Something squared, I should be able to write out exactly what that number is. We'll talk about that more as we get into these rational problems. Okay, so the last thing is the power of a quotient. If I have something that's being divided to a power, it's just like I did with multiplication. I can distribute that power to both of my variables or both of my numbers. So if I have 3/5 squared, well, this is 3 squared over 5 squared, which is 9 over 25. That's how I can work this out. That's how this problem works out. And why does that work again? Well, 3/5 squared, remember that's 3 to the 5th, 3/5 times 3/5. If I reorganize this, this is 3 times 3 over 5 times 5. So that's 3 squared over 5 squared. That's the reason why it works. But all I really need to do when I do this problem is to distribute that power in. So I get 3 squared over 5 squared. And then you can kind of combine these ideas. And so, how would I combine this? Well, if I had something like 3z over x all to the 5th power, well, I'm going to be doing two things. That 5th power can be distributed to the numerator and the denominator. So then I get 3z to the 5th over x to the 5th. But then that 5th can be distributed in here, and I get 3 to the 5th over z to the 5th over x to the 5th. Now, as a math teacher, I showed you that middle step. You could have gone from the green straight to the green and distributed the 5 into the 3, into the z, and into the x in just one step. But I was showing you why it worked. Okay? Those are all the examples I have. We'll have a warm-up, and we'll have some work over this in class. So I will see you on Tuesday.